Okay, so today we're going over growth and decay again, or exponential growth and decay. So I'm calling this a part 2 lesson, even though I'm just going to go over your practice problem from yesterday. So I remember that I did the derivation for this formula, so hopefully you understand it. But once again, you don't have to do the derivation for this, okay? Remember, with other exponential growth and decay problems, do start with a differential equation. Anyhow, let me pull up that problem. That's going to be my example for today, so it'll be short. Okay, so you already have all of this in your notebook. You don't have to write anything new. I just wanted to make sure that you guys were good on this problem because there wasn't a differential equation to solve, so it wasn't like the other previous problems that I did, or an extension of those. So, a hard-boiled egg at 98 degrees Celsius is put in a pan under running 18 degrees Celsius water to cool. Okay, so that means that T sub S is 18, and the 98 degrees is what T sub 0 is. And I'm just going to write 18 and 98, so everything's in degrees Celsius as you read through this. After 5 minutes, okay, the egg's temperature is found to be 38 degrees Celsius. So when T is equal to 5, the lowercase t, the big T is 38. How much longer will it take the egg to reach 20 degrees? So we're looking for little t when big T is 20. So here we go. Okay, if I plug in the first bit of information here, then we have this equation. That I'm writing out. And you can see how there is a value for C, and we're adding 18 to our exponential. C was 80, to get T by itself. So this is now a function, and you can plug into your function, but this will also help us find K. If you haven't noticed, K is missing. Okay, so we'll do that multiplication here. Well, we need to isolate it. Okay, so remember to subtract. You'll get 20 and divide by 80, so you get 1/4. And we'll do the ln on both sides to get that exponent by itself. So negative 5k will equal ln of 1/4, so k is going to be the ln of 1/4, or 0.25, divided by a negative 5. So you can write it like that. K is going to be approximately 0.277, but again, you can just keep it in its actual form. Okay, so that way we have more of a function that is exact than an approximate. So let's go back to our function. So it's going to be T is equal to 18 plus 80e. It's in a negative, well, it's negative times negative. So this will be positive times T. Okay, so the K value again is actually positive, so it will be a negative. And that's how we're going to end up cooling it, all right? So if we plug this all in with capital T equals to 20, okay, and that's supposed to be a plus. I apologize, I didn't realize it was missing before. This is not 180, it's just 80, so be careful, that was supposed to be a plus. And to figure this out is very similar to what we did over here with the ln. So keep it in your calculators. You're going to get T is to be approximately 13.305 minutes. Okay? Now, just going back, we're starting with a value, I guess circle with this color. T was 5, it wasn't 0. So if we subtract 5, we're getting 8.305 minutes. That's actually our answer, believe it or not. I put an approximate symbol, didn't come up very well. Okay, that's how much longer it'll take for the egg to reach 20 degrees, because we're starting it at after 5 minutes. Okay, so this is how much longer, and I boxed it, hopefully you can see it. So problems that students have are really just calculator problems, so make sure you enter the information correctly. And a lot of students forget to subtract 5, so now you have that heads up for future problems. Okay, so good luck and keep working on it. Let me know if you have any questions.